Imagine a world where your favorite burger wasn't raised on a farm, but grown entirely in a lab, free from the ethical and environmental burdens of traditional farming. Lab-grown meat is hailed as a breakthrough for sustainable food production, promising to reduce land use, conserve water, and eliminate greenhouse gas emissions tied to livestock farming. But beneath these compelling promises lies a pressing question. What are the hidden energy costs of lab-grown meat production? And do they undermine its eco-friendly appeal? To understand the implications, we first need to explore how lab-grown meat is made. It all starts with extracting animal cells, which are then cultivated in a nutrient-rich solution under tightly controlled conditions. Maintaining stable temperatures, CO2 levels, and nutrient balances is critical to the process, as cells grow into muscle tissue that replicates traditional meat. Scaling this process for commercial production involves specialized bioreactors, climate control, and a steady supply of nutrients, all of which demand significant energy. While innovative, this method relies entirely on human-engineered systems, making it inherently energy-intensive. One of the least discussed aspects of lab-grown meat is its substantial energy consumption. Facilities must maintain precise temperatures for cell growth, often requiring constant heating or cooling. The production of nutrient solutions, including amino acids, sugars, and growth factors, adds to the energy demands. Bioreactors used for large-scale cell cultivation require considerable power, unlike traditional farming systems that harness natural processes like sunlight and grazing. While traditional farming has its environmental costs, it's important to recognize that lab-grown meat introduces a whole new layer of energy dependency. Proponents argue that renewable energy can mitigate the environmental impact of lab-grown meat. However, this solution isn't as straightforward as it seems. Renewable energy sources like solar and wind are intermittent, meaning production facilities may rely on non-renewable energy during off-peak times. Additionally, the demand for renewable energy across sectors like transportation and residential use creates competition, making it unclear whether lab-grown meat is the best allocation of these resources. Even in an ideal world powered entirely by renewables, prioritizing energy for lab-grown meat over more pressing needs, such as reducing emissions in transportation and industry, remains a contentious issue. The environmental pitch of lab-grown meat often hinges on its ability to reduce greenhouse gas emissions, but the reality is more nuanced. Cows emit methane, a potent greenhouse gas, but it's part of the biogenic carbon cycle. Methane breaks down within a decade and is reabsorbed by plants, unlike CO2 from fossil fuels, which lingers in the atmosphere for centuries. Lab-grown meat's reliance on energy, particularly from non-renewable sources, could result in substantial CO2 emissions, shifting the environmental burden rather than eliminating it. A key but often overlooked aspect of the debate is crop production. Crops grown for human consumption and livestock feed require significant land, water, and chemical inputs. Monocropping practices deplete soil and harm ecosystems, contributing to environmental degradation. Traditional livestock farming, particularly pasture-based systems, uses byproducts from crop farming as feed, reducing waste and creating a form of recycling. Lab-grown meat sidesteps the need for animal feed, but doesn't address these systemic issues, potentially shifting the environmental costs without solving them. Beyond energy, lab-grown meat production has ripple effects that add to its environmental footprint. The production of growth media and bioreactors requires resource extraction, which can contribute to pollution. Waste generated during the process demands additional energy and resources for management. Keeping sterile, climate-controlled environments operational over time introduces ongoing energy costs that scale with production. These hidden costs highlight the complexities of achieving true sustainability through lab-grown meat. So, is lab-grown meat worth the energy trade-off? In the short term, its high energy demands may outweigh its environmental benefits. Over the long term, advances in technology and renewable energy infrastructure could improve its feasibility. However, global energy priorities must also be considered. With critical needs in healthcare, infrastructure, and transportation, the question remains whether allocating energy to lab-grown meat is the most effective path to sustainability. The path forward may lie in a balanced approach that incorporates multiple solutions. Technological innovations to improve energy efficiency and lab-grown meat production could make it a more viable alternative. Combining lab-grown meat with sustainable livestock farming, such as rotational grazing and holistic land management, could create a hybrid system that minimizes the environmental impact of both methods. Investing in diverse renewable energy sources and upgrading energy grids would support energy-intensive processes like lab-grown meat without compromising other sectors. Lab-grown meat represents a groundbreaking advancement in food technology, but it's not the environmental savior it's often portrayed to be, at least not yet. Its significant energy requirements pose questions about whether it meets the sustainability criteria it's credited with. While it has the potential to revolutionize food production, it must overcome significant challenges related to energy efficiency and infrastructure. Until these hurdles are addressed, lab-grown meat remains an impressive innovation with caveats. The road to a sustainable food future is complex and requires more than a single solution. Lab-grown meat is one piece of the puzzle, but understanding its hidden energy costs allows us to approach the debate with a clearer perspective. Ultimately, creating a truly sustainable food system isn't just about rethinking what we eat, but how we produce it, and at what cost. Thank you for exploring this critical topic with us. If this discussion resonated with you, don't forget to like, share, and subscribe for more insights. Let us know your thoughts in the comments below. How do you see the future of sustainable food production evolving? Together, we can navigate the complexities of innovation and sustainability to shape a better tomorrow.